Hi all, have a good day. I am K. Surya, working as assistant professor in the Department of ECE at SNS College of Technology. In this video lecture, let us see about 5G requirements under the concept of design thinking approach. So in design thinking approach, we have five different stages, which is empathy, then we have to define, then ideate, then prototype, and we have to test it. So you'll see this topic in design thinking approach concept. The first one is the empathy part. So with the proliferation of smartphones, IoT devices, streaming services and other data intensive applications, there is a growing demand for faster and more reliable connectivity. Significantly higher data speeds and capacity are needed, enabling the users to download and upload large files, stream high definition video and access cloud-based services more quickly and efficiently. Emerging technologies such as augmented reality, virtual reality, autonomous vehicles and Internet of Things applications require ultra-low latency and high reliability. A technology that drive innovation, create jobs and stimulate economic growth by enabling new business models, improving productivity and enhancing competitiveness is needed in this modern era. Smart cities and infrastructures also need to connect with a vast array of sensors, devices and systems. A network that enable efficient management of urban resources, optimization of transportation networks, enhanced public safety and security, and improved delivery of essential services such as healthcare and education is required. So next one is we have to define our problem statement. So here we are going to design a network which meets the growing demands of the current wireless networks. So current wireless networks are inadequate to the following growing demands. First one is insufficient bandwidth. Existing 4G LTE networks struggle to cope with the increasing demand of high-speed data transmission, especially in densely populated areas or during peak usage times. As users continue to consume more data-intensive content such as streaming video and online gaming, the limited bandwidth of 4G networks become a bottleneck. Next one is high latency. The latency or delay in current networks can hinder real-time applications and services such as autonomous vehicles, remote surgery and augmented reality. The latency of 4G networks, while generally acceptable for conventional mobile applications, is too high for these emerging use cases which require instantaneous communication. Capacity constraints with the proliferation of IoT devices and the advent of smart cities, industrial automation and other connected systems, there is a pressing need for networks to support a massive number of simultaneous connections. Existing networks struggle to accommodate the sheer volume of devices and data generated by these interconnected ecosystems. So next one is to overcome the inadequate coverage problems. Rural and undeserved areas often lack access to reliable high-speed internet connectivity due to the limitations of current network infrastructure. Extending coverage to these regions using traditional wired solutions is often prohibitively expensive and time-consuming, leaving millions of people without access to essential digital services. And the next one is security concerns have to be definitely improved. As wireless communication becomes increasingly pervasive and critical for various sectors, the risk of cyber threats and attacks also rises. Existing networks may not offer sufficient security measures to protect against sophisticated cyber threats, putting users' data and privacy at risk. Next one is the idea behind 5G revolves around advancing wireless communication to meet the evolving needs of an increasingly connected society. Here are the key ideas driving the development and implementation of 5G. First one is enhanced capacity and speed. 5G aims to provide significantly high data speeds and capacity compared to the previous generations of wireless technologies. By leveraging advanced signal processing techniques, spectrum allocation strategies, and antenna technologies, 5G networks can deliver peak data rates of several gigabits per second, enabling faster downloads, smoother streaming, and more responsive applications. And it also provides very low latency. One of the defining features of the 5G is ultra low latency, which refers to the minimal delay in transmitting data between devices and networks. This near instantaneous communication is essential for real-time applications such as autonomous vehicles and gaming, where even milliseconds of delay can impact the performance and safety. Next one is connectivity. 5G is designed to support a massive number of connected devices and sensors, forming the backbone of the IoT ecosystem. With its ability to handle a high density of devices per square kilometer, 5G enables seamless connectivity for smart cities, industrial automation, smart homes, and other IoT applications, unlocking new opportunities for innovation and efficiency. Next one is enabler for Industry 4.0 and digital transformation. 5G is expected to drive digital transformation across the industries, enabling a new business model, enhancing productivity, and unlocking innovation. In sectors such as manufacturing, healthcare, transportation, and agriculture, 5G facilitates the adoption of automation, remote monitoring, predictive maintenance, and other Industry 4 technologies, paving the way for smarter and more efficient operations. And also, as a global standard for wireless communication, 5G promises to provide seamless connectivity across the borders and regions, enabling ubiquitous access to high-speed internet services by fostering interoperability and harmonization of standards. 5G facilitates international collaboration, trade, and innovation, driving economic growth and social development worldwide. Next one is prototype. Here, prototype model of demonstrating the use of 5G for real-time video streaming is shown. So after the ideate stage, next one is the prototype stage. So we have to build rapid prototypes of 5G technology concepts to visualize, test, and refine ideas in a tangible form. Use low fidelity prototypes such as paper sketches, wireframes, or mock-ups to quickly iterate on design concepts and gather feedback from the stakeholders. As ideas evolve, gradually increase the fidelity of prototypes to simulate the functionality and user experience of 5G technology more realistically. Next one is testing. So conduct usability testing and feedback sessions to evaluate the effectiveness of 5G prototypes in meeting user-centric requirements. And also, once a viable design concept for 5G technology has been validated through testing, proceed with the implementation. Develop the necessary hardware, software, and infrastructure components to bring the design to life. Continuously monitor and evaluate the performance of 5G technology in real-world environments, gathering feedback from stakeholders to inform iterative improvements and enhancements. Next, we have to deploy the finalized version of 5G technology in the real-world settings, ensuring seamless integration with existing networks and systems. Monitor its performance, reliability, and impact on stakeholders, making adjustments as needed to optimize its effectiveness. Scale up deployment to reach broader audiences and maximize the benefits of 5G technology across various industries and communities. Thank you for watching this video.